Hello everyone, and welcome to Linux Forensics here at Pen Tester Academy. In this video, we're going to continue our discussion of live analysis, and we're going to talk about dumping RAM. As a reminder, our high-level process looks like this. We finally got out of box one, if you will. And now we've decided, yes, there was an incident, and this situation deserves a little bit more attention. So we're going to do some live analysis. So one of the first things we want to try to do, we've already collected a little bit of information in order to get to this point, and now we're ready to dump some RAM. Now, there's always a chance when you dump RAM that the machine might crash or something bad might happen. So you might want to gather a little bit of preliminary information first, but in this video we're going to talk about dumping RAM. Back in the old days, in the simpler times, if you will, it was easy in Linux to dump memory. There was a device called devmem that could be used to just dump every bit of memory. And there was another device called devkmem, which would dump virtual kernel memory. Why did these go away? These went away because they were a huge security hole. So you had this userland device that pretty much anyone could access, and you could access all of the memory on the machine. So this was a bad thing from a security perspective. So now these have been disabled or limited or just pretty much removed from any Linux that you're likely to encounter. If you can find a machine that still has devmem, it's limited to the first 896 meg of RAM. So you can't even get a gigabyte of RAM out of it. Now, if you're running a 64-bit Linux, there's absolutely no chance that you can use these devices. So what are you going to do? Well, the hard way. You can acquire memory images from a modern system is to create a new device that acts just like the old mem device. And this new device is called fmem, for forensics memory. And if you go to this link I provided here, you can download the code for this. It's pretty easy. You do a sudo make install, and then it works just like devmem used to. You can treat it just like a file. It's a little bit hard to work with, however, and there are a couple of issues. By the way, you should never be building the software on your subject computer. Obviously, this is going to cause some changes that you probably don't want to occur, especially changes in memory, which is kind of what you were after. You could build this on an identical architecture machine or in a virtual box if you don't have the same kind of system. Once you've built this, you can use the proc IOMEM information in order to determine which chunks of memory are interesting. Now, there's a couple of issues with this way. It's hard, it's very manual, that's one thing. And another thing that you'll run into is the fact that you won't have an image that's usable by things like volatility. And really what you'll have is an image that you can use for some simple searches, and that's pretty much about it. So that is the hard way. The preferred way to get memory is to use Lime, the Linux memory extractor tool. Now, some things you need to know about Lime. It's a great tool, but it must be built for the exact same kernel And again, don't build this on your subject machine. If you have an identical version of Ubuntu to what the subject machine is running, you can do this super easy. You can just run sudo apt-get install lime-forensics-dkms. This will build and install Lime for you. So for every other situation, you need to go to the GitHub for Lime. By the way, those of you who might have read a book, a very good book called The Art of Memory Forensics that came out recently, all about how to use volatility, you might note that they have outdated links in that book, which is not surprising given how books are made and how long it takes. Here's the current link. You go ahead and compile it. Now, we'll show you a little bit later how you can do this. And the only thing you need to know is if you're not compiling for the same operating system as what you're currently running, you just have to tell it where to get the right kernel headers. All right, other things you have to do with Lime. You have to pick your format. It supports multiple formats of output. So raw is the most basic form, and what they do is every chunk of RAM that they get, they just concat it all together. So if you're just doing some simple searching, this is probably fine. There's also padded. Padded is the same thing as raw, but wherever there were gaps, maybe some reserved areas, instead of concatenating everything together, it puts in zeros for those areas. And there's the recommended format of Lime. The Lime format contains metadata. And essentially what it does is it stores your memory output in a structure. That structure has metadata embedded inside of it. You also have to pick a destination. The two most common destinations would be a file or a network port. If you're going to put it out to a file system, again, do not put it onto the subject file system. You could put it onto a thumb drive if you have one large enough, or even better, onto a hard drive. I say even better because, as we all know, thumb drive write speeds are horrible. If you put it to a network port, you just use a netcat listener on the other side, and off it goes. And the general syntax for using Lime is just sudo insmod, insert module, whatever your Lime module is called, and then you give it the parameters path equals wherever you're setting it, and format equals your chosen format. And that's pretty much it. So it's very simple. Well, that's all for this video. In the next video, we will go and show you how to actually use Lime and some of these other tools. As always, if you're enjoying these videos here at Pen Tester Academy, please tell a friend. We'll see you soon.